Hello, everyone. Thanks for being here today. Thanks also to those that were up late tonight discussing on the open source panel with us. So today I'm going to talk about Next.js. My name is Guillermo Rauch. I'm the founder of Zeit. We make a deployment tool called Now. And I'm going to talk a little bit about it because we have a philosophy for the tools we write, especially for those of you that haven't heard about Next.js. I'll give you a little bit of context about where it comes from and what it does. So we have this Tolkien-inspired idea of having one command to perform the most important task in your life. We think that there's just too much boilerplate for things that we do far too frequently. So when it comes to deploying a website or an API, we invented this tool called Now. You go to any directory, whether it's a static project or a Node.js server or a Dockerfile-based Linux container server. We give you this one command that takes that project to the cloud. You get a URL back by just writing Now. And taking this experience from the CLI to team collaboration and the web, we wanted to enable something where people could collaborate. So we wanted to build this really rich web UI where you could see the logs for your deployment, the source code, the overview, the state, the newsfeed, and all of these things. And we had some pretty big ambitions. So we wanted it to feel almost like GitHub, where every team or person has a dedicated URL within the website. We wanted to enable server rendering for great performance, and we wanted to also, once we render something, update it in real time, because when you deploy something, when people are visiting it, or when it's being scaled, there's a lot of data that changes on the back end, and we need to communicate it to the client as fast as possible. So it was a pretty tall order. We wanted all these things, and we also had this expectation of how things should work, that they shouldn't take, so much configuration and so many different steps and commands and incantations. And that's where Next comes in. So I'm going to describe what Next does for you in 3 very simple steps. So you go to any brand new directory in your computer and you install Next and its peer dependencies. So something really cool about this framework is that it gets out of the way a lot. So for example, it doesn't really ship with its own version of React, React DOM, or even associated utilities like ESLint and so on. It's basically just a framework that renders the pages. So you install it and you choose the version of React and the React DOM that you want to use. The second step is you create this pages directory, which is where your entry points or top-level components go. And I'm going to get more into this later when I talk about code splitting, but the fundamental idea is that you start with one code splitting entry point, which in this case is the index of your application. And I pre-populate it with a stateless functional component. Here, you could actually also export a React class. So what Next is doing really is just providing the minimal amount of glue between your React components and rendering them from a web server or as a static file. The last step is you run Next, and that's it. You go to localhost, and you get your beautiful page. Since I created index, it's mapped to the root of my web server in this case. There are 3 really interesting things you get for free by just running Next. One of them is hot code reloading. So any change you make to the files gets automatically reflected on the web UI without even pressing refresh. The second thing, and what drives a lot of people to this framework, is server rendering. So you can get any dynamic data, and when you load the page already comes with all the HTML, style sheets, and as I'll go more into it later, all the necessary script files for your system to load. And what's really cool about this is we recently introduced a command called Next Export. So if you don't want to use a server, you can actually export all those individual entry points as static HTML files. So it's very cool. The technology that enables this is, as I showed earlier, you have a stateless component or a class. You have to add an additional hook, which is get initial props. For those of you who remember the initial React API, it used to call the method getInitialState. So you can think of this as a counterpart to getting the initial state for a component, getting the initial properties with which that component has to be rendered. And perhaps the most interesting feature of them all, especially when it comes to scaling your applications, is code splitting and routing. So earlier I called my page index.js, but you can actually call it anything inside pages like AJS and BJS, and those will be mapped automatically to routes, which you can later override if you so desire, but you get up and running very quickly this way. And within those files, it's the same story, just export functions or classes that render your application. The idea here was to provide something that also goes beyond technical accomplishment, which is team scalability. And what I refer to by team scalability is this idea that you can divide the team of people that are working on the front end into specific sections, and their work can complement each other much better, and the performance of one file doesn't bring down the performance of another, for example. So if a particular section on your application is growing a lot, when those bundles are generated, it's not going to impact the work of others. And also it configures an emergent convention, that I call it. So typically what you end up with is you have a pages directory and a components directory. Inside that components directory, you keep all the reusable stuff that those higher entry points will use. So as you get started using Next with the team, it's very easy to make progress and to not become slow over time. So automatic route mapping can actually take you very far. So one example that you can check out is Next News. So every time I create an example for Next, obviously I prefix it with Next, and this is the basically clone of Hacker News. And what I did with this is I actually set out to create an identical clone because I wanted to show off that we had the capability to, at the very least, have the same amount of power as a traditional server rendering stack. So Hacker News was written, I think, 20 years ago, and they just booted up a server, had some data in memory, and printed out some HTML. And so far, it's done very well because it hasn't changed much, and I'm pretty sure that a lot of people in this room go to it quite a while, possibly even right now, at this very moment. But what I also wanted to show was, okay, once you have the server rendering part, you can actually use a React lifecycle, such as component did mount, component will receive props, and so on, to augment that initial rendering of the component. And for example, you can load more data. You can update the data. So a particular detail that this version of Hacker News has that the original doesn't is it updates the number of votes in real time, it can load comments dynamically, and so on. So it kind of shows you what you can do, and as I was saying, automatic page to route mapping goes very far because I was able to clone the entire site without using any custom server code. So far, this is basically what you've been able to do until the most recent release of the framework, which is you can set up a bunch of top-level components and get some initial data and take advantage of code splitting. So the workflow up until now, and I think for a great majority of applications that are out there today, is you load some code, either on the client or on the server. It gets some data. And then the typical, the UI is a pure function of data thing. You take the data and you render the page. But in many cases, as I'll show today through some really compelling examples, I hope, the data can actually determine additional code that can be loaded. So this is why I called this presentation code as a function of data. In many cases, the API calls you make, the result of a GraphQL query, for example, can determine actually what additional code has to be loaded in order to very efficiently load up your application. So I'm developing a new case study following my convention. It's called Next.js. It's very funny, thank you. And it's a clone of Messenger. So it's actually trying to be very simple. So what it does is obviously allow people to communicate with each other and switch between conversations using the Next.js page system. So this is the very basic implementation of a conversation. You get to it, there's no data, you populate it with some data. In this case, I'm using state so that I can have it offline and then reconciliate it later, etc. So the first highlight that I want to point out that Next enables kind of out of the box is that server rendering makes for a really nice experience. So let's see if this GIF triggers. Yeah, sorry for the slowness. I'm going to play it here because my computer is sort of struggling with the full screen. Hopefully you can see it. Okay, there you see it. So messenger.com actually doesn't server render. So what you get, first of all, is a white page. Then you get a slim gray bar at the top. And you see that even the layout is missing from that initial load of the page. Then the route sort of changes, and then there is a spinner, and then there is a final conversation of Alex telling me to show up for the conference. So obviously, this is a much more simplistic implementation, but I simulated some backend latency to show you that the main difference is when you server render, it's up to you to decide how much data to load with that initial paint of the page as that HTML starts flowing down the pipe from your server. So what's cool about this is, as the developer, you decide how much you want to pre-render, and you decide what that initial first experience looks like. For example, you can optimistically render a layout, or you can render the conversation and then lazily load the sidebar, etc. So the spectrum here of server rendering is you can render the most basic thing, which would be maybe a spinner or a shell of what the eventual layout would look like, or in many cases you want to render what's above the fold, or you can actually go ahead and, depending on the performance of your backend, decide to render the entire page. So the next highlight that I want to discuss today is what can we do to lazily load code as a function of data. So the basic implementation of my thread contains a text component. And that's a component that will make up the great majority of conversations that you have because it's a chat application. So I decided that the text component is part of the initial bundle for the code splitting entry point of my thread, of this basic page. So if you look at the URL, in this case, I think it says Rauch G, which is me, which maps through a custom server. It maps to our index entry point. So this example also aims to show you the ability to set up fancy, so to speak, routing. But the text component always comes with that main JS file that matches that index.js entry point. So if you were to inspect the output of the JavaScript files that Next.js compiles for you, you would see that you will find that text component inside the main bundle because it's commonly used across all entry points, which in this case is one entry point. But for Nextinger to actually be a realistic reincarnation of its counterpart, we have to imagine that we have a potentially really big list of message types. So imagine that I'm configuring my entry point or my top-level component, and if I started to import everything that the user can possibly ever see, I would, first of all, have a huge list of imports, which doesn't look very good. Second of all, the bundle size would increase. And third of all, this kind of takes away of that idea of scalability from the performance standpoint and from the standpoint of, you have a bunch of people working perhaps on different message types. Some perhaps so obscure that they target maybe only a certain segment of your user base, for example. So you wouldn't want to, over time, have 3 pages of imports in your entry point. So the question really is, how can we lazily load code yet retain those initial benefits of a slick initial load, not showing spinners that are unnecessary, and so on. So what we want to do essentially is get rid of that basically deterrent from that initial paint. We want to render whatever messages are on that last page with that conversation, and we want to make sure that they come with the page, yet we also want to make sure that they don't belong to the main code splitting entry point, because what we're dealing with here is the code that we have to load depends on data, and the data is dynamic, and it depends on each user and so on. So the answer to this conundrum is to make the dynamic import, which is supported by Webpack and we were able to get up and running with very quickly. We added basically server rendering support to it. So the way that it looks like, and this API is evolving, and so we're currently working on this in the beta branch, so expect this to change a lot. But the basic idea is, when we get that initial data, in this case, in my conversation entry point, we invoke a component that we tell Next is async. And I'm going to get into basically the subtlety of it's not really async. So when you look at the implementation of the thread component, you look at how we await the import of this different message types. So what we're doing on the Next.js side of things, when we already do this actually for style sheets. So when you're incorporating styles in your different components, we compile the styles and we include them at the top of the page, so that first of all we deduplicate. We don't want to include all the styles for every time a component shows up. And second of all, we want to include critical styles at the top so the page renders in a very nice way. So what we did is we took this idea and we applied it to import. So the only requirement is that you call this render async method. So what's happening underneath the hood is import on the server side runs synchronously. So as you know, render in React is synchronous. So we can't really await something. But there's a possibility that if import we can manage to run synchronously on the Node.js side of things, we use require, and then we just hand it out to React and the initial render of the page. Then additional script tags are included for subsequent components that get added on top of that entry point. So an example that I have here is a conversation with my co-founder Naoki about my dog, Day, the most beautiful dog in the universe, if you ask me. So as you can see, that initial render didn't really show a loading spinner, not even at the component level. React already has everything that I need to render that entire thread, even though that photo component does not belong to the entry point. And if we inspect the initial HTML that comes with the page, you're going to see that we're referring to a Webpack chunk that belongs to that lazy import photo component. So this is all happening automatically for you. From your perspective, you just use the dynamic version of import, but Next.js automatically divides main entry points and code splitting entry points and the components that actually have to be loaded as a function of data. So if you take two distinct conversations or two distinct users, you would see that the script tags that get rendered for each change. So this happens because we can make import work synchronously in the server. And on the client side, before we tell React to reconciliate the code with the HTML that came with the page, we already loaded that script tag. And as a bonus thing that is really nice is another thing that you get for free with Next is you get link preload tags. So when we send out the HTML of the page, let's say the user is on a slow connection and they get maybe the first portion of the HTML, the first packet, or because of the sliding TCP window, they're only able to consume so much. Notice that we have a symmetry between preload components on the top and script tags that get loaded at the bottom of the page in parallel. So the really neat thing about this is, as the rest of the page renders. Off thread, thanks to link rel preload, we're downloading and parsing the script tags that then we're going to need for Reactor Reconciliation. And for those of you not familiar with the implementation details of React, reconciliation is that React receives some HTML, and it needs to basically hydrate the component that resulted in that HTML so that when you have, for example, lifecycle hooks, you can access the properties of that component, for example. So the really neat thing about this is this API also gives us the power to tell the user how much, or basically decide on behalf of the user what components need to be rendered before we perform a certain paint. An example of this is a naive implementation of this with some higher order component would result in, for example, as you switch between conversations, you could end up with missing messages or missing message types. So you would have, for example, if a certain initial render didn't have the photo component, and then you switch to a conversation that needs it, you actually would want to make the conversation wait on getting that photo component. So I have an example here because I'm taking advantage of the transition system, and the initial render didn't have the code to load the photo, but when I transitioned, I waited on everything to be fetched. So that's why you see the bar at the top. So that's a very interesting implementation detail. And yeah, again, this happens when if the user beforehand didn't have that code, then again, when they render some other data set, they're going to need it, and you want to decide how long you wait. So perhaps an even more interesting example is, okay, I already loaded the page, and I receive through a WebSocket connection, for example, a new message type that I haven't ever heard of. So in that case, you do want to show the loading message. So I have an example here where I'm receiving through the push channel the message type map. So notice that first we see a loading tag that corresponds with the code being fetched. But I'm talking about the code being fetched for that specific component, which is the map. And then that actually comes with a huge tree of components from React Google Map, and that in itself loads Google Maps. So imagine if you included that with a page. It would be quite the expensive inclusion for a very small percentage of messages that require it. So as we were working on this, we realized, there is a library that already implements this, that perhaps just like we can treat import specially, we could in the future treat fetch specially. So it would allow you to write even more succinct code where in the component that returns the rendered elements, you could also await on stuff. Because potentially we could rehydrate when we rehydrate the page, we can say fetch, actually, we already have that because we loaded it on the server. Here is the data that it resulted with, and then you can reconciliate very quickly without making another HTTP request. So I want to thank for this interesting set of improvements Aaron Noda, one of our core contributors who actually is working on this implementation, Sven Zolo, I hope I pronounced it correctly, who wrote Async Reactor, which gives you that API that I just showed, but only on the client side. And Sasha Eiking, who I've been discussing some ideas around fetch and React Server recently with. If you want to learn more about Next.js, I recommend that you go through our history of blog posts so that you get context for how the project has evolved and the reasoning for features that we've added and so on. The main GitHub project, of course, which contains the entire documentation for the framework. That's, I think, a nice feature, is that the README of Next.js has everything you need to know. And then you can go to Next News, and hopefully soon you're going to have Next Messenger available also under Now Examples very soon. And if you want to discuss it, you can also tweet at me and ask any questions. But I have already seen some questions come in, which I'm going to talk about now. So what is the best approach to start with Next? Actually, the best approach to start with Next is hopefully have an internet connection, is learn Next.js.com. Oh, let me put that on full screen. I think I have to use another screen. Oh, there it is. So this is a really amazing guide to get started with Next, because it walks you through really small lessons that take maybe like 10 seconds each. It's fantastic. It was built by Aronode as well, who's very prolific. How hard is it to migrate an existing code base using React and Webpack? So the neat thing about Next.js is that it uses Webpack. Unlike Create React App, we decided not to go with the route of ejection. What we allow you to do is we allow you to decorate the Webpack config through a function that you can supply. So we basically create a Webpack config on your behalf, and then you get it through a function, and then you can augment it if you want to customize Webpack. And similarly, we also build on top of Babel. So you can define a Babel config in package.json or Babel RC, and you can define your own syntactic extensions like private members in classes. What are you more proud of now or next? Most of all, I'm proud of the naming. I think it's really cool. Now, next. What's next? I don't know. Next pre-render versus PWA. I think pre-rendering and PWA are perfectly complementary. I think it follows the pattern that Google calls PRPL, I think it's called. I think server rendering is always a plus because of, I wrote an essay about this, but the fundamental idea is if you go to a certain URL that contains some information about the data that you want, such as github.com/Zeit, the server already knows what data you're interested in, and it can perform a huge number of optimizations on your behalf, like streaming HTML, like pushing data that is going to be required later on. So pre-rendering is always a desirable trait. Now, PWA, I think, is always a desirable trait as well, because if you can take any website and augment it to become a more sticky experience with more capabilities, that's also great. So in order to make a PWA with Next today, you have to configure your own service worker. So we don't do it automatically for you. But that might change in the future. We haven't yet actually built a PWA for ourselves. So something that kind of determines the future of all of our decisions is our needs for our main application. That's why I started giving you context of what features we needed out of this. So we haven't yet built a PWA, and this is why, for now, it's reserved for user-land code, which I think is a fairly acceptable trade-off. How do you handle code splitting while also caring about authentication and permissions? So this is a really good question. In order to, for example, have a designated part of your application that can, even whose code can only be accessed by a certain kind of user. So the typical example here is you want to have an admin section, for example, for your application. So what you do there is you can set up a Express server or even a vanilla node HTTP server, and you can add authorization to those URLs that I showed earlier that serve the code. So if you really can't share, for example, the code itself or like an admin panel because it's revealing of certain features, or you don't want to give away your upcoming releases and so on, you can actually add authentication also to that part of the code that serves the code. Yeah, so we actually do that as well. And it's fairly easy to do. When you involve a CDN, you want to keep in mind that CDNs have to revalidate based on, for example, the cookie header varying or whatever. So it's finicky. It's not super trivial to do, but the main reason is authentication authorization is not ever easy to do. Dynamic routes, static export, what's next for Next? I wrote this on a GitHub issue, Our main goal right now is we recently surpassed 1,000 React components, and what we've been facing is some code scalability or code-based size scalability issues. So, for example, if you want to maintain hot code reloading and you want to watch the entire file system and you want to rebuild upon change and certain things like that, things become pretty slow if you have a ginormous code base. So a lot of the work that we're doing right now is we're polishing what's already there so that it scales really well. So that goes for hot code reloading, error handling, and so on. So we want to take a step back after this major features land and really ensure that the developer performance and user performance is optimal. And some features that I would guess might become more relevant in the future are, for example, something that makes it easier and less error-prone to configure those service workers. But other than that, I think maintaining that API, maintaining the simplicity of that API is more important, I think, than adding a lot of features. How do you handle a piece of state that is common for multiple pages? That's a great question. So when you invoke getInitial, or when getInitial props gets invoked, when getInitial props gets invoked, you get the request object if you're on the server, or you don't get the request object if you're on the client. So what we do for Zeit is, when we detect that we're on the client, actually this is not a good example because we load data from GitHub, so you saw that progress bar. But in this, we load the code mirror dynamically, so you saw that progress bar. But see how this page is transition immediately, yet here we have user state. So that user state is actually shared across pages. So we have an authentication little utility that knows it's running on the client side or on the server side, and when it's running on the client side, it maintains the state. And then we use a higher order component to synchronize the state across tabs. So for example, if I go to Zeit again and I log out, so notice it logged me out here as well. So not only can you share state, but because we basically maintain that state inside the top-level component that wraps all our pages that need authentication, we use the React Lifecycle hooks to subscribe to changes that could come from other tabs. So in this case, we use local storage events to talk between tabs. So what's happening is that top-level component has a user object in state across all pages. And then when we get a message from another tab, we call this.setState user null. And then it propagates down the pages. So different pages react differently to the news that you no longer have a user. So that's where component will receive props comes in. Because here, we don't really mind that we no longer have a user. So the only impact is that my face went away and got replaced with a login text. But in other pages, for example, if we had been on the dashboard, there is no dashboard that actually works when you're not logged in. So on component we'll receive props, we perform the side effect of redirecting to the home page. So that gets a little too technical, but the TLDL is, too long don't listen, is we have state at the top level component, and we can synchronize it across pages, and it's global, which makes for a beautiful optimization that you don't load common data across pages. Offline support for Next. Actually, we're working on this, and this is why I was mentioning that you can set up your service workers yourselves. We're working on making a, the next question is really funny. We're going to make our documentation completely offline, and we're actually kind of there because I didn't go into this yet, but you can watch my ReactConf talk if you want to listen to this. But we have prefetching of other code splitting entry points. So if you come to this page, all the code splitting entry points for all the other pages that use the link higher order component, it's basically prefetching those entry points in the background. So if I were to go offline right now, especially now it's fetching all the blog posts. If I were to go offline right now, I would have access to everything. Like, this is already there. So what we have to do to make this work offline is very minimal. We just have to say that whenever you come to the page for the next time, like, just load whatever version you last had. And then because of all our code splitting entry points and all our script tags, as you saw earlier, are identified by immutable hashes. So there's actually no risk of the code getting stale, or when you reconnect, there's no risk that you don't know to reconciliate new code. This also gets a little bit too technical, but imagine that you've gone offline for a very long time, then you regain connection, or you load some page that you hadn't loaded before. If you've made a new deployment that changed your scripts, Next is able to distinguish that the code running on the server now is outdated, and it performs a hard refresh, or it gives you a hook to take over and decide what to do when there's a code mismatch. So this is a very interesting new problem that has emerged from all these dynamic code bases, which is you load the page, and an engineer at the company just deployed a code change, and meanwhile, you're lazy loading that page. What happens, for example, if the server no longer knows about it? So Next.js actually deals with that pretty elegantly. So this is something that I think most of the people in the world should not have to worry about. So it's one of my favorite features. Are there any plans to support Vue.js along with React? Thankfully, and this is actually quite a fascinating story and a testament to the pace of open source nowadays, when we announced Next.js, someone in the Vue.js community announced Next.js, which is a name that I really like. So I highly recommend it because it's a very funny name. It satisfies the good name precondition. And it does very much like the similar thing as Next, but they've actually taken it further, and they're kind of adding a lot of features that we don't have. Like, they did static exports before, so they're very productive. There's something about the Vue community that makes people really productive. So the gist is we don't have to do anything because Next did it. That's great. Is Next in Jira a breach of React terms of use? I don't know. I don't think so. But if it is, we'll rename it to Next Chat or something like that, something more boring. How does Next deal with dynamic dependencies for the client code? And also, what does it use under the hood for code splitting? Basically, most of the heavy lifting is done by Webpack. Webpack does all the, maintains the graph and decides what code goes into what chunk or entry point, etc. Something else that's worth mentioning is when you lazy load a component on the client side, sometimes it might take a while to load. Obviously, it's not immediate. Or it might fail. So our async rendering decorator also gives you the ability to set up a component for error case and for the success case, which is very similar to how React Loadable or async Reactor do it. So it's actually very easy to do. It's very easy to deal with dynamic dependencies in the client code, and at the same time, it's very difficult because notice that we have to think so much more about all these finicky user interactions. If we're naive about it, we might load a page that has like a bunch of like loading little texts all over the place. So all the problems that come with asynchronous programming are exacerbated, obviously, here because we're loading a lot of stuff that can fail. And what do you do when it fails? Do you tell the user to refresh the page? And if it's a little component, do you tell them right there to refresh the page, or do you like have some like global notification system for telling the user to refresh the page? And does the user even care about refreshing the page? Should you do it automatically? But what if when you refresh automatically, you go into a loop of refreshing automatically? And yeah, so it's easy, but it's I would say it's simple, but it's not so easy, or some combination of that. Yeah, so that's the last question, and thank you very much.